Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0135-01, indicates a malfunction in the air-fuel ratio AF Sensor 1 heater circuit of the 2023 Honda CR-V. This sensor is critical as it measures the oxygen levels in the exhaust gases, which helps the Engine Control Module, ECM, or Powertrain Control Module, PCM, regulate the air-fuel mixture for optimal combustion. Located before the catalytic converter on the exhaust manifold, the AF sensor is designed to provide the PCM with precise readings. When the heater circuit of this sensor fails, it prevents the sensor from reaching the required operating temperature, leading to the DTC being stored. This malfunction could adversely affect vehicle performance, engine efficiency, and emissions control. Under DTC P0135, the AF sensor, Sensor 1, is the focal point of the malfunction. This sensor calculates the ratio of air to fuel entering the engine, crucial for maintaining optimal combustion. Located on the exhaust system, its heater allows it to operate promptly. If the sensor detects an issue with the heater circuit, the PCM, or Powertrain Control Module, interprets this as an abnormal signal, which triggers the DTC. The error diagnosis also involves checking the external circuits, like the IGPS LAF and AFHTN circuits, for any faults. Finally, the PCM itself is examined, as any malfunction within this central control unit could also cause the DTC to trigger. The potential causes for the DTC P0135-01 include a faulty air-fuel ratio AF sensor. If the sensor fails, it may not return the correct data to the PCM, rendering it inoperative. Circuit malfunctions, such as broken or corroded wires, can prevent electricity from reaching the sensor's heater, which is integral for its operation. Finally, a malfunctioning PCM can also lead to this code being triggered. If the PCM fails to control the sensor adequately, it may misinterpret signals or fail to invoke necessary error codes, resulting in performance issues. The symptoms associated with DTC P0135-01 generally manifest as poor engine performance, characterized by rough idling or hesitant acceleration. This is due to the engine running lean or rich, as incorrect data from the AF sensor can lead to improper fuel mix adjustments. Moreover, increased exhaust emissions can be anticipated, as the fuel combustion may not be optimally managed, impacting the vehicle's environmental compliance. Drivers may also notice the check engine light, CEL, illuminating on the dashboard, indicating that further inspection is required. This occurrence is a clear sign that the engine management system has detected a fault that affects performance and emissions. In the first troubleshooting step for DTC P0135-01, the process begins by starting the engine and holding it at 3,000 RPM without load, which means that the vehicle should be in either park or neutral. This step is crucial as it allows the engine to reach optimal operating conditions where the heater circuit will be engaged. As the engine runs at this speed, the technician should observe when the radiator fan activates. This is typically a sign that the engine is adequately warmed up. After the fan operation, the vehicle should be allowed to idle. Monitoring these conditions helps establish a baseline operation for the AF sensor's performance. In the second step of troubleshooting for DTC P0135-01, the AF sensor, Sensor 1, connector needs to be disconnected. Once disconnected, the technician will examine the connector pins for any visible damage, corrosion, or oxidation, which can hinder connectivity. Following this visual inspection, internal resistance must be measured using an ohmmeter. At room temperature, The expected resistance should be between 2.8 and 4.5 ohms. This measurement indicates whether the internal circuitry of the sensor is intact or whether there could be a malfunction that might be contributing to the stored DTC. If the resistance is out of specification, the sensor may need to be replaced. In the third troubleshooting step, the IGPS LAF circuit must be inspected. With the AF sensor disconnected, the technician sets the ignition IG mode to on and checks for battery voltage, which should be approximately 12 volts for this circuit. This is a crucial step because a lack of voltage would indicate a break somewhere within the circuit or a failure in the power source. Confirming normal voltage is essential as it affects the AF sensor's functionality. If the voltage supply is abnormal, further investigation into the circuit is warranted. This could involve inspecting the wiring for damage or ensuring that connections are secure and free from corrosion. In the fourth troubleshooting step, technicians need to jump the SCS Service Check System line using the HDS Honda Diagnostic System before disconnecting the PCM connector. This action primes the diagnostic system to ensure accurate readings and prevents unnecessary errors. Once the SCS has been jumped and the required wait time of more than 1 minute has lapsed, the technician then disconnects both the A/F sensor and the PCM connectors. The next part involves completing an inspection of the AF-HTN circuit by checking continuity and resistance. The resistance should indicate less than 1 ohm to confirm no open wiring issues. If abnormal, this suggests a defect somewhere in the circuit. The fifth step of troubleshooting involves inspecting the PCM connectors after ensuring both the sensor and relevant circuits have been assessed. Disconnecting the PCM allows for a deeper examination of its internal circuits. Should all previous tests show normal readings and conditions, the conclusion can be drawn that the PCM itself may be the culprit behind the DTC P0135. Analyzing the internal circuits involves checking the connectors for signs of corrosion, poor connections, or other mechanical issues. If the PCM is deemed defective, replacement may become necessary, ensuring that all connections are secure to prevent future occurrences of similar DTCs. The final repair verification step involves restarting the engine after completing the necessary repairs based on diagnostics. Upon restarting, the technician must utilize the HDS to clear the DTC P0135-01 from the system memory. This action resets the onboard diagnostic system, allowing it to begin a fresh evaluation of the engine's operation. Subsequently, the technician should monitor the vehicle for any reoccurrence of the code or associated symptoms during a test drive. Proper verification ensures that the problem has been rectified and allows for the confirmation of repair integrity. Successful verification means the vehicle is restored to optimal performance without DTCs. Preventive maintenance plays a key role in avoiding future occurrences of DTC P0135-01. Regular inspections of the AF sensor and its connections can help identify potential issues before they become significant problems. Additionally, technicians should ensure that all connectors and circuits are clean and free from corrosion to maintain reliable electrical connections. It's also essential to confirm that the voltage supply to the sensor is within the specified range, as improper voltage can lead to premature sensor failure. By implementing these preventive measures, vehicle owners can enhance the longevity of their components and maintain optimal fuel efficiency and performance. In conclusion, addressing DTC P0135-01 involves understanding its implications thoroughly and adhering to a systematic troubleshooting approach. Key points covered include the necessity of inspecting the AF sensor, checking external circuits, and examining the PCM for faults. Recognizing the importance of each component's role in the vehicle's performance is crucial for accurate diagnostics. Furthermore, preventive measures can significantly reduce the chances of future DTC occurrences, leading to fewer repair instances and enhanced vehicle functionality. Proper understanding and maintenance contribute to a smoother driving experience and more efficient vehicle operation overall. Please like and subscribe to the channel. See you next time.